In this video we're going to look at an introduction to the sine rule. First thing you need to know about the sine rule is that it doesn't just apply to right angled triangles. All the trigonometry that we've done so far this year has been for right angled triangles, but the sine rule applies to all triangles. So let's begin by drawing a triangle on the screen here. And we'll label some of the angles and sides. Now if I call this angle up the top here angle A, and this angle angle B, and this angle angle C, we can label the opposite sides as follows. The side opposite angle A we'll call side small a. The side opposite angle B we'll call small b, and similarly the side opposite angle C we'll call small c. Now what the sine rule tells us is that the length of side A divided by the sine of angle A is equal to the length of side B over the sine of angle B, and that is in turn equal to the length of side C over sine of angle C. So that's the sine rule. More probably though, you'll be using only two of those terms instead of all three. So you'll more often than not see it written as simply A over sine A equals B over sine B. Okay, now that's all well and good, but how can we use this information to solve problems? Well, let's look at an example. If we have the triangle, which is shown on the screen here, we can put in some information that's given to us. We may be told that this side is 22.5 centimetres, this side is 15.8 centimetres, this angle here is 112 degrees, and the question is, what is that angle there? So what we have here is a situation where we have two sides. We know one of the angles opposite one of the sides, and we're asked to find out the angle opposite the second side. So in simple terms, we have two sides and one opposite angle . What is the other opposite angle? Now we can use the sine rule to solve these sorts of problems. The sine rule says A over sine of angle A equals B over sine of angle B. So let's label a few of these. If we call that side angle A, here, then that will be side A. This will be angle B, and that will be side B. So let's fill in some of those details in our equation. 22.5 over sine of A, which is 112 degrees, put that one straight in, equals 15.8 centimetres, which is side B, over sine theta, the unknown angle. Now let's use an algebraic technique called cross multiplication, where we move that term to the top line on the other side and that term to the top line on that side, and that gives us 22.5 times sine theta equals 15.8 times sine 112 degrees. Simplifying that further, we have sine theta equals 15.8 times sine 112 degrees over 22.5. That means that sine theta equals 0.6511, or using the inverse sine, theta equals 40 degrees and 37 minutes. So we can use the sine rule to solve problems where we have two sides, one angle opposite one of the sides, and we're looking for the angle opposite the other side. Okay, let's look at another example. In this example we have a triangle and we are told that this side is 14 centimetres, this angle is 18 degrees, and this angle here is 33 degrees, and we're wanting to find this side. So we're in the position where we have two angles, one opposite side, one side opposite one of the angles, and we're wanting to find out what the other opposite side is. So let's use our sine rule. Writing it down again, A over sine of angle A is equal to the length of side B over sine of angle B. Filling in the details, side A will be our known side, which is 14 centimetres, and the opposite angle to that is 33 degrees, so that'll be over sine 33 degrees, and that equals x, the unknown side, over sine of the opposite angle to x, which is 18 degrees. Cross multiply, we get 14 times sine 18 degrees equals x times sine 33 degrees, which becomes 14 times sine 18 degrees over sine 33 degrees. And if we work that out on our calculators, we find that it gives us a value of x of 7.9 centimetres. So we can also use the sine rule to solve problems, or to find out lengths of sides where we have two angles. We have the length of one side opposite one of the angles, and we are looking for the length of the side opposite the other known angle. There is one thing to be pretty careful of when we're working with the sine rule. The best way to illustrate it is to just do a couple of examples. If we work out with our calculators the sine of 60 degrees, we'll get the answer 0.866. But if you punch in 120 degrees, you will also find that the sine is 0.866. 0.66. So two different angles can have the same sine. We haven't had to worry about this up until now because working with right angled triangles, the triangles have always been less than 90 degrees. But using the sine rule, there might be situations where the angle is greater than 90 degrees. In which case, we will be given the solution sine equals 60 degrees, which is less than 90, even though it's obvious that the angle is greater than 90 degrees. If we can see from the diagram that the angle is greater than 90 degrees, we need to realise that the angle we want is in fact the complement of the angle we're given. In other words, sine of 180 minus theta is equal to sine theta. So let's illustrate that with a simple example. If I have a triangle like this, angle A, and I'm working out what angle A is, and I find that sine of A equals 0.5, then I work out the inverse sine of that, and I'll get the answer 30 degrees. But looking at that, it's obvious that that angle is not 30 degrees. It's quite a bit larger than 30 degrees. And the reason for that is that it's bigger than 90 degrees, and therefore we need to give our answer as the complement of 30 degrees, which is 1A actually equals, it's the wrong answer, actually equals 180 minus 30 degrees, which equals 150 degrees. So that angle is 150 degrees, because 150 degrees gives us the same sine of 0.5.